Okay, so this is the Junior Certificate Higher Level Maths Paper 2 for 2018, question 2. Phil is an athlete. The graph shows the number of calories in kilocalories she burns per hour, depending on her average heart rate. The axis does not start at 0, 0. So here we have on the x-axis her beats per minute, her average heart rate, and on the y-axis we have the calories burned per hour in kilocalories per hour. First thing we have to do here is use the graph to estimate how many calories Phil would burn in 1 hour if she had an average heart rate of 170 beats per minute. So all we got to do here is go along here to 170. We got to go up along here and work out where that is on the y-axis. So we go up here till we hit the graph, then go across here, use a ruler. I'm doing it freehand here. So we get 750 kilocalories per hour. So that's my first answer here, 750 kilocalories burned in 1 hour. Okay, so the next one then is part 2 here. Use the graph to work out Phil's average heart rate when she burns 300 kilocalories in 30 minutes. Well, 300 kilocalories in 30 minutes. Now remember, on the y-axis here our units are kilocalories per hour, so you got to convert this to hours really. So we have 300 kilocalories in 30 minutes, so that's just equal to 600 kilocalories in 1 hour. So we've got to go up to 600 and do the same thing again, but just in reverse. So we're going to go across again, use a ruler here. So we're just going to go, let me see if I can get this right. Okay, so there we go. So we're going to go across from 600, then we're going to go down, and this should give us our answer, which is 155. So it's halfway between these two, so it's 155 155 beats per minute. Okay, so that's it for part A. So part B is where Phil runs a series of stages. In each stage she runs a slow run of 60 meters and then a sprint in each stage after stage 1. So she does a slow run first, then a sprint run here. Here we have the total distance and here we have the stage numbers. Okay, in each stage, after stage 1 she sprints 50 meters more than she did in the previous stage. So you can see here she does a slow run for 60 meters. The first stage she runs 50 meters at a sprint, and the second stage then she does 50 meters more at sprint, and so on. She's doing 50 meters more each time here. Complete the table below showing the distance that she runs slowly and the distance that she sprints in each stage, as well as the total distance per stage. Give the values in the last row in terms of n where appropriate. Okay, so let's just fill out this table. Well, she's going to run 60 meters slowly in all stages, so that's going to be 60 here. Now here she's going to sprint 50 meters more at each stage. So here she's done 50, she's done 100, 150, so the next one is going to be 200, 250 here, and we'll just fill this bit out, these two bits out in a minute. The total distance here is going to be 60 plus 150, which is 210. 200 plus 60 is 260. 250 plus 60, 300. 300 here and 10. Let me just redo that. 310. Okay, so what about these ones down here? Well, if you look at, we need these ones in terms of n if possible, so, or where possible. Now if you look at this number here, this is, she does 50 meters in the first stage, 100 meters at the second stage, which is 2 times 50. Here she does 150, that's actually 3 times 50. 4 times 50 will give us 200, 5 times 50 will give us 250, n times 50, or just 50n, will give us this value here. Now what about this part here? Well, she's going to do 60 meters anyway, so we have to include the 60 meters, and then she does this 50n as well, so it's just going to be plus 50 n. So her total distance will be 60 meters plus 50 times n, the stage number. So you can see here it's actually a linear sequence of numbers here, but anyway, we're not asked about that. Okay, let's have a look at part C. In one of the stages, Phil runs slowly for 60 meters at 2 meters per second and then sprints 150 meters at 7.5 meters per second. Work out Phil's average speed. Okay, so let's just have a look at this. Now the average speed for this particular stage is going to be, you've got to remember that speed here is equal to distance, or total distance, divided by the total time, the overall time. So the average speed over a race is going to be the entire distance divided by her total time. So this is what we've got to work out, her average speed. So we've got to work out the total distance and the total time. Well, let's look at this particular stage and see what kind of distances and time she's doing. Well, she's going to run, this is the slow stage, if you like, the first part of it. She's going to run slowly for a distance of 60 meters, and she does a speed of 2 meters per second. 2 meters per second. So we can actually work out the time here. The time is going to be distance over speed. In this particular case, her time will be a distance of 60 divided by a speed of 2, which is 30 seconds. So she's actually going to do 30 seconds over the slow part of this stage. Now let's see part 2 then. She does a sprint then. The sprint, she does a distance of 150 meters, so the distance is going to be 150 meters, and she does this at a speed of 7.5 meters per second. 7.5 meters per second. Again, we can do the time here. The time is going to be distance over speed. So her distance was 150, her speed is 7.5, and when you do that you get 20 seconds. 20 seconds. So we can just add these two here. That'll give us her overall time, the total time here that she does this particular stage at or in. Now we have the total distance as well, because we have the distance she does the slow stage, we have the distance she does the sprint stage, so we can just add these two to give us the total distance. So we have the total distance, we have the total time, so we can work out her average speed for this particular stage. So let's just do that. So her average speed therefore her average speed is going to be the total distance. Well, the total distance is 150 plus 60. It's her total distance, divided by her time, which is just 30 plus 20. So you get 210 divided by 50, and that finally is, just work that out, whoops, I'll just cancel that for a second, and what do we end up with? 210 divided by 50, which is 4.2 meters per second. And I think we were just asked work out Phil's average speed in meters per second. Well, that's it exactly, 4.2 meters per second. Okay, and that's it for this particular question.